Accurate description of DNA basics nocive prenatal screening. Introduction. Cell-free DNA basic nocive prenatal screening, which has also been called noninvasive prenatal diagnosis and non-invasive prenatal testing, is now offered by several companies that use various analysis methods. This screening has been reported to have higher detection rates for trisomy 21, Down syndrome, 29.0%, trisomy 18, and 26.8%, and trisomy 30, 22.1% than previous non-invasive prenatal screening methods.
Accurate and comprehensive, non-invasive prenatal screening is here. Natera has created the Panorama Prenatal Test to ensure you are giving your patients the best-in-class information regarding their pregnancy. Panorama can be used to screen for common fetal aneuploidies of chromosomes 21, 18, 13, X, and Y as early as 9 weeks gestation. How does Panorama test for these abnormalities? When a woman is pregnant, segments of DNA from the fetus enter the mother's bloodstream via the placenta. So, all the Panorama test requires is a simple blood draw from the mother. Once the lab receives the sample, the DNA is amplified on a sequencing machine, which allows for analysis of the specific parts of DNA that are unique to each person. These parts are called single nucleotide polymorphisms, or SNPs. The Panorama test looks at SNPs from both the mother and fetus. By looking at these SNPs, the test can determine parts of the mother's genotype as well as parts of the fetus's genotype. This method performs equally well across all chromosomes and allows the Panorama test to report risk scores with extremely high accuracy across all conditions tested. This method is unique from other non-invasive prenatal tests that all rely on something called counting, or a quantitative method. These methods take the maternal blood sample and basically count the total number of chromosomes present. This approach has inconsistent amplification during sequencing that makes it difficult to determine any differences between the expected amount of DNA compared with the observed. It is especially problematic on chromosomes 13, X, and Y. The Panorama prenatal test has been studied in multiple clinical trials with the best results in the industry. All test result reports will show an individualized risk score for each condition. Certified genetic counselors will call referring providers to discuss any high-risk results. Visit www.panoramatest.com to learn more.
Objective: to investigate pregnant women's level of the future interesting is non-invasive prenatal diagnosis (NIPD) and what factors may affect expected uptake of this testing.
The American College of Obstetricians and Gynecologists currently recommend that all pregnant women be offered screening for fetal chromosome abnormalities. In the United States, this is currently performed in a number of different ways. In the current study, we compared sequencing of DNA fragments that flowed in the bloodstream of pregnant women to the current standard blood tests and ultrasound tests. The results of the study showed that the DNA testing performed significantly more accurately than the current standard of care. Specifically, the false positive rates with cell-free DNA testing for trisomy 21, also known as Down syndrome, and trisomy 18 were significantly lower than the current tests. In addition, the positive predictive values, meaning the chance that there is a true positive case associated with a positive screen, were tenfold higher for trisomy 21 and fivefold higher for trisomy 18 as compared with the current standard of care. The significance of this is that significantly fewer women, if they have a positive screen, will need to have an invasive procedure. This could improve prenatal care by making it safer, and therefore we recommend that prenatal testing using cell-free DNA merits serious consideration as a primary screen for fetal chromosome abnormalities.
Methods: writing questionnaires were admissions to women in their first trimester.
VDC. The DNA Diagnostic Center performs 3 out of 4 private paternity tests and is the most recommended and accredited DNA paternity testing laboratory worldwide.
DTC is the #1 testing facility in the U.S. for paternity testing. We've tested over 1 million samples. Every year we get over 800,000 calls related to paternity testing. DTC's non-invasive prenatal paternity test is innovative for the following reasons. Currently, prenatal testing can be performed by using a sample from amniocentesis or chorionic villus samples. These are invasive technologies that carry some risk of a miscarriage with the technique.
The technology is unique because it finally gives us the ability to perform paternity tests on women who are pregnant in a non-invasive way.
Our testing can be done safely, reliably, and anonymously without the involvement of your doctor.
This is revolutionary technology that we think is going to change the scope of the maternity market.
This test will allow you to resolve a very stressful issue that you may have in your life. DTC's non-invasive prenatal paternity test is a simple 3-step process. Step number 1, call DTC. Your case consultant will carefully explain the process and begin by coordinating your blood collection. We have over 2,000 facilities to ensure a convenient appointment for you. Step number 2, get the blood draw. This is a simple blood collection and involves a small amount of blood from both the mom and the alleged father. And step number 3, get the test done and the report, and that will determine who the biological father is of that child.
We have consultants who will walk everyone through the entire process and reassure them that it's safe, it's convenient, and it's 99.9% accurate.
The test can be performed as early as 9 weeks gestation. We're looking at over 300,000 genetic markers. The tests that are done currently using an amnio sample.
However, evidences of the actual performance of non-invasive prenatal screening in the general population is limited. Furthermore, discordant results between non-invasive prenatal screening and traditional cytogenetics analysis has been observed despite the high sensitivity and specificity of the analysis.